Hi everyone, good morning. Thank you so much for joining me here today. Woo! So today I'm bringing you all a Copernicus talk. And the start of the show is the Confi Copernicus framework, which is the integration of ComfyUI into Houdini. And the idea is that we want to bring to Houdini the building blocks for you to create your own hybrid CG and AI pipeline, mixing Houdini modular and procedural tools with the state-of-the-art of generative AI through ComfyUI diffusion architecture. What does that look like? It looks like that. In Houdini in ComfyUI, in Houdini Copernicus, we have a compound graph where you can have access to all ComfyUI nodes, and you can just kind of start building away like you would inside of ComfyUI, and then you can just bring all your data from Houdini, rasterize it, and just pipe it in on the right inputs straight away. Allows you to do image, videos, 3D, audio, and anything that ComfyUI supports at the moment. So to make this happen, we have a whole family of nodes that we're introducing here. The blue one is the compound graph, where all these nodes combined together can do a lot of different things. We have the blue one, that's the ComfyUI in a COP node. We have the yellow ones, which allows us to convert different ComfyUI nodes into Houdini nodes. We have the purple ones that are feature providers. We have some workflow specifics that kind of match specific things that you can do in ComfyUI you can do in COP. So we kind of have a loop that allows us to do so. We also have a lot of utility nodes to help us bring data in, out of Copernicus, and also we made a few ComfyUI nodes that also help us kind of navigate this idea of like interchaining between computer graphics and CG. And we also built a couple of easy to do straight up workflows using HDAs. And we also have a top submitter that allows you to submit different ComfyUI jobs using tops. So we're going to see today that pipeline in action through this exercise where we are doing a performance capture with a mocap suit. Then we bring that to Houdini to do some retargeting. And then we then jump into the hybrid pipeline by using OpenPose to build a control net that we can then do image generation. We can also guide image to video. And then we're also going to be taking a look at upscaling with Seed VR. So we can kind of go from those 640 images to kind of full HD image, for example. So my name is Rafael Drelich Valentin. I'm an image processing TD at SideFX, and I'm also a designer and senior visual effects artist. And I'm also Houdini instructor at two polytechnics at Toronto. And this project wouldn't happen without collaboration and participation of Anatolii, which is the developer of ComfyUI integration. He's also a senior pipeline developer at Digital Pictures, a senior FX TD as well. And only those who work with Anatolii know the danger, the power, and the passion that he carries around. So I'm very excited to work with him. So why a CGI pipeline, right? So GenAI is this magical thing that can do code, images, videos for us. But in 2025, it can do so much more. This idea that you can just provide two images and they can combine together, or you can maybe do a concept where maybe you want some images, you want to explore what's in between them is very powerful. As an artist, when I look at this, I'm just kind of, wow, what are the possibilities that I can do if I bring this to my 3D environment? So not only these changes are reshaping how we interact with digital media, but they're also reshaping how animation projects are done, right? So Runway ML was featuring earlier this year this idea of you just design your first frame and you record yourself, and now you can move the character. So that was kind of very mind-boggling for me, and I was like, okay, how do I get to know and get involved into this and just adapt to that? So as an artist, looking at all these, you gotta actually go to a service, you gotta pay a fee, you gotta, do so much to actually access those new features and have access to those proprietary AI models that as an artist, I felt, okay, so is Gen AI kind of going away or have a divergence motion to computer graphics? Is all the skills that I learned gonna go away? What's happening, right? So I felt that CG might be away from Gen AI, and I had fear about that. But as I got more into it and studied more this idea, I'm starting to understand that maybe CG and AI have a space to converge, right? There's maybe a CGI interspace there, intersection, that there is a lot to explore there. And the idea for this is to propose strategies for creative professionals, adapt their practices, and in response to those emerging technologies. To give you guys a timeline of what's happening, I had early discussions about, playing or just investigating impacts of Gen AI into VFX and games that started in September and June 2024. Then I decided to make this a topic of my master's. And by January 2024, I decided that, okay, I'm going to research how we can use Gen AI to shade and render and explore things. I proposed that to SideFX, and SideFX took me in as a image processing TD through my field placement. Basically, is a sort of a co-op internship where you kind of join the company to explore the project you want to do. And right after that, Anatolii joined the effort. And maybe a couple of days after, we already had our first node that allows us to bring data in and out of ComfyUI. So from there, on May, we demoed some of that, provided an early version of that integration. In June, we started beta testing with some folks. In August, I completed my master's, and the topic of it is GenAI and how GenAI is reshaping digital media and our practices. And now we are in October, so that's HIVE AI. To give you guys an idea what I explored throughout this process, basically I did from February to June a lot of image processing workflows. Then in June, we took a look at 3D generation. Later on, we looked at multi-frame and batches using ComfyUI. And just now, we started looking at video and animation. Throughout that process, I was doing a lot of master research, all of that part, and then I wrote my thesis in a couple of months, and I delivered it. And here we are in HIVE AI in October, and now I'm reporting to the community what I've been doing with this. So before we dive in, I just want to give you all some information that some of the AI models we're going to use today, they are not ethically sourced, or may not be, but we are building this so you can actually have access to any type of model, even those who are actually ethically sourced. And we also anticipate that new models will be delivered by IP providers, that you can actually use those without with proper copyright. And the hope is that this research creates pathways and discussions on how to move forward with GenAI in an ethical manner, always putting artists in the center of the spot. So the idea that I have for this project is to empower digital artists to create and customize their own AI workflows within a familiar professional interface, bridging the gap between GenAI or cutting-edge GenAI with established production pipelines through Houdini. And we're going to see the main course of the day is this pipeline that uses mocap to guide video diffusion. All right, so that's the video. On the top, it's our mocap performance. Then we bring to Houdini to kind of adjust the pose and not be only constrained to my body shape. Then we do an analysis of the performance to create a skeleton that can then control GenAI. And then we use that skeleton to guide the process for diffusion for video that allows us to kind of move any character that you desire to move. So how does the pipeline look like? That's kind of, we have a mocap in a different software, then we bring to Houdini, do the retargeting, and then we jump to Copernicus to operate ComfyUI through there. For the mocap component, I'm just using my laptop. It's a very simple laptop. We are using Perception Neural 3 and Axis Studio package to do the mocap and data processing. Very easy to get started. It was very fun. Just to get the suit on, you need some help because there's a lot of sensors and a lot of things to go on. But it provided very reliable capture, very non-noisy results, and just very grounded. Very easy to export from the software as well. You can have a variety of formats. We are using FBX for this example. And it's also important to highlight that you can also do live capture, what allows you to kind of use the mocap stream node in SOPs to grab the data live from the software and just bring to Houdini and either do retarget and just see that happening on your character in the end. So it's a very powerful pipeline, and I encourage you all to experiment with it. It's very fun. So retargeting itself is very straightforward. We bring the FBX on the top, we process it a little bit, and then we just do rig match pose, map points, and full body AK. So the actual body of the retarget character can actually move, and we just render it. Get maybe some depth paths, some normals if we want, but that's pretty much our process for the mocap part. So that's done with the initial part of the pipeline. So now we're going to jump into control nets, image diffusion, and video diffusion. So for that, we definitely need a stronger computer. We are running with a 5090 now and a much bigger bandwidth of RAM and a much stronger processor. And all of this is happening in the ComfyUI compound graph, which is the front end of ComfyUI inside of Houdini. It allows you to automatically exchange data between Houdini and ComfyUI. It's compatible with a lot of other different assets that can be generated there. And on the interface of the node, it allows you to have a server address where ComfyUI is running. It can be either on your local network, on the cloud. You just got to have a path there to access where the server is running. You can decide where you want to save the contents. And then you can also, we have a really cool button here that allows you to press one button and bring all the nodes that are installed in ComfyUI and make them available in Houdini. Just one click. So if you're not familiar with ComfyUI, what is ComfyUI? It's an open source user interface for Diffusion, and basically have a bunch of different nodes that allows us to load different models, create prompts, and also perform the diffusion and also the encoding and decoding of the latent so we can actually get the pixel image, which is very powerful. It's also model agnostic, so you're going to be able to do video, 3D, or diffuse any other things that's available on the market. And it's also node-based, just our favorite tool, Houdini. So, and what is ComfyUI in Houdini? Is an external plugin. We support Confi core nodes. We also have partial compatibility with third-party nodes, only those who have JavaScript actions on the interface that we cannot support. And all the ComfyUI nodes, they only show when you're inside our ComfyUI compound graph. So when you're using COPS, you don't get all the different ComfyUI nodes showing up as you're doing your query for tools to use. Only when you jump into the specific context of ComfyUI, then you have access to those. We also added support for drag and drop, which is pretty cool in ComfyUI. Basically, once you save a GenAI image, you can just bring that image to ComfyUI, just drag and drop it, and the whole network of making that image shows up. You can replicate that, so we brought in that feature also to Houdini, so you can just bring a JSON and just kind of make sure it just kind of pops in, and you can just replicate whatever you found on the internet. So how do you get started with this? Basically, you got to install ComfyUI, you got to download the different models, you got to manage all of that data using ComfyUI, right? But then, if you want to bring to Houdini, you got to install the plugin. So the plugin is very simple. We have a folder for Houdini, a folder for ComfyUI. Just drop those two files where they need to be. And then you're ready to get started. So you need to have ComfyUI running on your background on your computer or on the cloud or whatever machine is running on your local network, and just access that through a address. You got to dive into COPS and just have fun. So we're going to do some image generation right now. For that, we're going to be using QuenImage, which is a open source model. Allows you to get prompt in English and also Chinese. It can render text and images very nicely. And you can also create and edit images. So for example, this example here, the image, you can just ask for an image of the clothing of the character, and it's going to try its best to look at the image and provide a new one just showing the clothing, which is very powerful. Here we are using for research, and this is distributed under Apache 2 license. So to build that network in Houdini, we just go to ComfyUI, export that from ComfyUI as a JSON, and then bring it to Houdini very easily inside of Confi Copernicus node. And if you've never done ComfyUI, this is how the image network looks like in it. We have the pink nodes that's going to load different models. We have the green and red nodes that allows you to prompt positive and negative prompts. The yellow one's going to do the diffusion process for us, or denoising of the latent. And then we do the VAE decode to grab the image from the latent into pixel space, and then we just output that image. If you're not familiar with GenAI or ComfyUI in general, what are diffusion models? They are pre-trained models that they learn how to add noise to an image, and then they learn how to retrieve that given image from the noise. Then we have Clip, which is another neural network that you need to load in order to make this work. The Clip will handle text tokens and kind of does a relationship between text and images. And we also have VAEs and latent space that we already had an awesome class on that idea. But we can handle how we compress data into the latent and how we decompress that data, right? But when that data is compressed, it's compressed with the semantic information that allows it to be organized. And on the video here, you're just seeing what we call latent walk. It's just us walking around the latent and see what that outcome relates for us, which is very powerful. And basically, this technology allows us to process large amounts of data very fast. And the idea is that if you're processing pixel space, it's very hard to compute, takes a lot of time. But if you're processing things on the latent space, it's very fast. So we come back to that image, and we can see now we are loading our diffusion model, loading our clip, and loading our VAE for that given model. And then we bring our latent space generator here, our empty latent, which is just a noise, and then feed all that into the denoiser, which is the K-sampler, and that guy will do the diffusion in steps for us and generate the image. If you haven't seen a diffusion process happening, here we have a diffusion of an image happening in 20 steps. So on the top, we can see the progress throughout those 20 steps. It's kind of generating that image for us. We have a predefined visualization happening in ComfyUI. And then from there, we're just gonna, once it completes, the image is decoded from the latent, and then we get the final image in pixel in all its glory. Fun. So we have a very long prompt to provide a very detailed information about what we want to see on that image. And now that we have our image we want to use, we're going to jump into guiding the image, how we can have one image and just pose it differently, right? So for example, this guy has a very interesting pose, but it's not the one that I want to start from. So for that, we're going to use a different neural network, which is a control net one. Basically allows us to condition Gen AI using pixel images. And what control nets here, I have the paper if you guys want to know a little bit more, but the idea is that you can provide some information to the AI model, and it's going to try to do its best to reconstruct the image using that as a guide. So on the Canny Edge example, we just provide some hints to the AI model to then fill the rest of the image following those guides, right? So if you change your prompt, the image will stay consistent because it's trying to recreate around the provided information. Same here for the actual human pose. We can provide a human pose, and Gen AI will try its best to actually generate characters that match that pose. So how are we going to bring that conditioning practice? I recorded myself being very silly, doing this lookout and a bunch of other performances, and we're going to use that performance to guide the given image. This is what it looks like this in Copernicus. We bring the video, we transform and crop, so we can only need to analyze the actual portion where it's me, not the rest of the image. And then we do have a ComfyUI Copernicus network when I'm generating the open pose. And it's important to say that the open pose generates a 2D image of the skeleton, so there's no 3D there. So we cannot really grab this image and move an actual skeleton. It's just 2D information. Fun. So inside of that Confi Copernicus, this is what we have. Input, a range to batch, the open pose processing, and the outputs. The ComfyUI range to batch is one of our nodes that allows you to send batches of frames to be processed in ComfyUI. So here I'm just sending a range. The open pose has its own inference model that allows inference of a human body or creates a skeleton for you based on a specific set of images. And you can say if you just want the body, if you want the face, or if you want the face and the hands. And you can also define the output of that image size. Then I ran this for myself, and I also ran this for the retargeted skeleton. And this is the outcome, right? The two skeletons, they are similar, but they are also very different in output. My camera, the idea here is that when you do a open pose from what you filmed, you constrain to that given position of the camera and that given body. But when you retarget, you can have different body shapes and different types, and this can control different character sizes. And I also felt that doing the estimation from a CG character provided a bit better output than just doing video capture. Basically, there is less data for the model to analyze, so the inference is a bit better. And then I use those to guide the image diffusion, right? So you can see that if I just use my body and ask to actually recreate the character using my body, the character looks a little bit like me, like hunched and big bones. But if I use my character, I actually get like the mage that I was looking for. The mage is kind of tall, opponent, kind of very lean. So that's the image we're using, and these are the results compared on the skeletons. And this is a network, right? So it's important to say that control nets, they have different flavors. Sometimes they're going to show up their own unique model. Sometimes they're going to come as LoRa's. So the network you're going to have in Houdini or in ComfyUI will change a little bit. But once you get familiar with what are control nets, it's pretty much, you feel very comfortable manipulating them either way they come. And these are some of the results again, right? So that's the reference image, and these are the two characters we generated. One is more what I was looking for. The other one is like, okay, not exactly. And just one more comparison. And I also did this for another character. This is a source from the ComfyUI documentation. And you can see that if I propose my body to move this character, it's also got my features, which is not what I was looking for. I'm definitely looking for a more lean character. So the takeaways, the mocap retarget was easier to perform on the CG character. I had more freedom to explore different type of body proportions, and I also felt that the results would kind of just best overall. So I just want to bring this takeaway here as well, that I'm using here a non-licensable character, but this could be your CG character, right? It doesn't need to be the AI generated one, which is no licensable because it's coming from a AI model that might be ethically sourced. So now that we have the character, let's add motion to the character. Let's get some guiding AI videos. For that, we're going to be using 2.2 to do the video, which is a video generation model that allows you to describe different types of scenes and get results out of it. And you can describe, for example, things as such as angle of the shot, lighting conditions, who is on the shot. It's a very descriptive video model. It allows you to do text to video, image to video, or even audio to video, which is very fun. We're going to be using 2.2 font control here, again, used for research and distributed under Apache License 2.0. This is a network in Houdini. We also are loading unique AI models to do the VAE, the clip, and also the diffusion model. But we also have the red ones, which are bringing image inputs and also our control net data. And the star of the show here is this node called 2.2 font control that allows us to define the output of the video size, but also how many frames we want to generate. And basically, you're just providing a reference image, and we are providing a sequence that is the animated body. So here to bring the ComfyUI sequence, the sequence image that we generated in Houdini, we have the ComfyUI range to bash just to bring that sequence into Houdini and make that upload. So that's the outcome. We have a very cool character that is moving, following my performance, and also we get for free some fire motions, some interesting motions everywhere. Generation was very fast, under 3 minutes, 30 frames per second, and we use a lot of RAM because we have Houdini and ComfyUI running on the same machine, but the video memory, we didn't kind of cap the 5090. It ran around 25 gigabytes of RAM. And these are the two skeletons, right? You are able to get your performance on both characters, but I much rather the result that I got from the mocap one instead of the actual video one. I just felt that it was a more natural one. So takeaways from this, it's very fast, very easy. You can do a lot of different characters. I was very surprised that video AI models are also compatible with control nets. It kind of opens a lot of opportunities there to explore. And the question now is, how do we push that from 640 to kind of 720 and kind of full HD? And to do that, we're going to be using SeedVR, which is another AI model that's for upscaling and picture restoration. Very interesting. You should definitely check it out. It can do image or video upscaling with some consistency. And is also implemented by the community into ComfyUI. And what we are doing here is just going from that 640 image to a 1440 image. And this is kind of what it looks like in a single frame. So basically, you get a lot of data retrieved. It's very interesting to recover data. And here's the same wipe. And you can see how we got a lot of extra information out of it. The sphere is very interesting. The hair got a lot more detail. It changed a little bit the face of the character. But overall, very interesting result. I don't have a video here today. I'm still processing that at home. So what is that network in Houdini, right? So we have the image generation, then we do the video diffusion, and then we do the video upscaler. And these are just 3 different setups, and they all can be uploaded via top networks to an external machine that's running that. And a video upscale is the network that you see here on the far right. Basically, a couple of different nodes, bring the model, make some manipulation of that model, and make some changes. And I just want to also give a huge shout out to Adrian Tupet, who has been helping me with this topic of upscaling. So you should definitely check him out. And he's also a VFX veteran who's also exploring AI, which is very interesting. So that sums up this initial part of like, okay, let's explore images and video generation. So what else is possible when we have that integration happening? So I want to show you some examples done of 3D generation for meshes with AI. So where do you start? On ComfyUI, they also have a bunch of different templates and examples. You can just go there and grab those examples very easily. And then you bring them to Houdini. You just drag and drop your JSON and you bring it in. And that's kind of the network that I'm going to demo right now, is the idea that we have one ComfyUI Copernicus network for image generation. Then we do another one for generating the 3D. And then we have that 3D export as a GBL file. Right into Houdini, you can just kind of do whatever you want with that. And so basically, we're going from these rocks to like a fiery rocks that we can use in our game or different resources. So mesh generation is definitely harder. It took around a minute to generate this mesh. And we are using Haiyan 3D to do that performance. So this is what it looks. It's very simple network. Again, we're also loading an AI model. This time is a checkpoint instead of different AI models. The checkpoint kind of already have the VAE, the clip, and also the diffusion model all in one node. And then we also have the diffusion, which is the red node that allows us to do the diffusion, not only of images, videos, but also 3D meshes. And then once you have the assets out, you can jump into SOPs for mesh optimization. So I just kind of converted to VDBs, did a quad remesh, and then measure some curvature, and then do some auto UV, our favorite Houdini nodes. And then we just kind of bring back to Copernicus, and then we do some sampling to get the UV space, do some texturing, maybe sample our curvature and normal out of that, and then we can do our shading and get the final image you guys saw earlier. So it's very interesting to have like all of that in one space, not having to leave different applications, just be able to do one thing straight away, and maybe also output them in series using the top exporter. We end up also exporting high-end texturing pipeline that allows you to use generative, UV unwrapping, texture projection, and some other things. And we came up with this specific node that helps, you can do all of it, generate the image and generate the 3D in tops. And there's a little demo of it here. Just kind of get the image, you prompt enough, you get to the image you want, and then you just press generate 3D, and you get the 3D out of it. It just takes like 4 or 5 minutes in the 4080. And that's just not the final one. You cannot really use that as a production, right? You just definitely need to retopo, redo the mesh, not the mesh, sorry, the textures, so it can actually look appropriate. But it's a very good starting point for a process if you don't have the model, right? That's how the network looks in our top. We have a node for Gen Image, a node to remove the background of all data that you don't need. Then we have a Gen 3D. It's definitely a more complex network here. Basically, we have some area that's doing the 3D generation of diffusion in green, UV unwrapping purple, and texture projection on the pink side. And then you export as a GOB. And once you have that with the top submitter, you can just kind of pump out a bunch of different models. So here we're just doing some Roman vases with weird images projected into them. Or we can do an infinite rotation of different statues. You just kind of have a top network that generates different nodes and just kind of go, and you can have a very big library of content very fast. What are the takeaways here? It's a very interesting workflow. I was very happy to kind of explore with that process. It goes very well for SOP, for mesh processing optimization and cleanup, even better with COPS because you can generate new textures that actually make sense for you. And it's also very important to mention that the components to do the texture part and texture projection, they are a little bit hard to install. So it's not super user-friendly, but it was worth the process just to get familiar with it. You can also export so much more, text, audio, and others. Basically here we are running LLM through ComfyUI, and then that can we have a string save node. Basically, I provided an image, I provided a request for Quen VL, and they can say, just tell me a story about the image, and it can give him a story right into Houdini as a text file. It's not back into Houdini right away, but it just kind of saves the text file with it, saying like, well, the image showed 3 mugs on a wooden table and so much more. And I think that's very interesting because I wonder what we can do if we start labeling the data that we have in our libraries and having the label and start making creative use of the labeling, right? So I think that's a very interesting workflow to explore. In ComfyUI, you can save so much more. WebP, WebM, GIFs, and so many other formats. So we created a solution, which is a partial ComfyUI graph, which is a nested prompting solution. It's a prompt within a prompt, and that allows us to save any other format that ComfyUI export very easily. Well, it's a little bit more technical. Basically, you have to go inside of there, use the save node. Basically, only in that context, you're allowed to see all the different save nodes that ComfyUI offers. And then you just got to parse the information that ComfyUI exports as a return, right? So here we are pointing to the node, and then we say audio, or we say images, or we say other information that you can just kind of bring it back. So that's kind of the explorations we did. So then we provided this to a group of beta testers, and I want to provide you guys some information from that beta testing. So we did the Toronto Houdini user group, and from there we got a lot of hits. We provided a forum. We got 140 hits of people wanting to play that. Lots of love and community that we got from that forum. People were like excited by the idea of CGAI. And what look for us in the chart here is like, how long have you been using Houdini? So most of the people that were interested were like Houdini seniors with 6 years plus. And a lot of them have dabbed into ComfyUI already. We don't know if they dabbed in a commercial project or just exploring, but the takeaway here is that Houdini seniors are definitely experimenting with ComfyUI and kind of trying to get upskilled. So we run this private beta from June to August. We define a mirror board where we kind of have all the tutorials installing process with a lot of documentation, written and video. We also did weekly check-ins with the participant and got, a lot of feedback out of that. We did 15 videos instructing people how to use, how to download, how to generate all of these assets, which was a very fun experience to do. And I just want to give a shout out to Grid Markets that they provided an ambient for us to use ComfyUI in the cloud. So it allows us to do processing not locally, right? Relying on a cloud computer where I can actually have a ComfyUI instance running with the models pre-installed and also with a beefy video card. So they also provided some resources for the beta testers. So just giving them a huge shout out and thank you. What are the takeaways out of that? So from the 55 users that we invited, they provided amazing feedback to us. And also there was a lot of conversations around the ethics around this, what to expect on the future, and also what are the limitations on the studio use, and if this is even possible to be used. So that was very powerful conversations. But from that data set of users, again, we brought in mostly Houdini seniors, 75% of them seniors. And in that sampling, even more of them use ComfyUI. So it just kind of goes into the idea that people are exploring with that. And I just want to give you a shout out to some of the folks that provided a lot of insightful feedback. Eldad, Adrian, Eldad that's here, that's going to present for us later on today. Adrian Tupet, Imre Toke, Fabrício Chamon, Ivan Reason, Pratik Redmond. Thank you for participating and providing us unique feedback out of this. And what's next on this project, right? We are gearing it up for a public release. So if you want to sign up, we have this QR code. If you can just going to go to a form real quick and you can just kind of experiment with that. I'm just going to leave it on the screen so everybody can just check it out. And then you can just kind of sign up, give them some information about it and just let us know what you feel about that, because it's important for us to understand how the artists feel about that, because we're using that for the artists. So I'm going to leave for one more minute. Sweet. I hope everybody got it. All right. You guys got it? Awesome. Perfect. And the take here is that we are exploring what's possible in the intersection. We're just getting started. We now build the foundation to the exploring. And soon, not only me, not only the beta users, more people will be doing that. So I'm really excited for that next step. If you want to follow the project, you want to learn more about it, we have another QR code here. You can also connect with me, and I'll be happy to talk about it or even do a quick demo of you. So not of you, for you. So thank you so much, guys. And thank you to Side Effects for hosting us here today.
Thanks, Rafa.
Let's
Questions?
go.
Yeah.
Thank you for the presentation. I have a question because one of them really touched close to home on the mocap. So you did two versions. You did one, you're doing video to what was it called? Open source and open source.
Open pose, yeah.
Yeah, open pose, thank you. Open pose then to VGen. And then you said, okay, you had the suit, you converted that to geometry. So my question was, the way I interpreted your workflow was that you went mocap to geometry to basically retarget, then that to open pose, then that to VGen. What I was curious about, why were you not able to go directly from mocap to the video gen, like by creating the skeleton? Is that because the way I interpret that is that skeleton is just an image that the decoder just interpolates. Why did you need to regenerate it? What would you not able to go directly to it?
Yeah, I understood the question. So why did we?
My own question.
No, it's pretty good. And like, why did we actually rebuild a human moving if we already had me moving, right? So the idea there is that the open pose skeleton color tells the algorithm which is ways forward and backward. So the color of the bones tells side and left and right. So I definitely want to explore just having instead of retargeting to an actual human body, retargeting to a skeleton that has a coloring. I haven't done that yet, but I think it would be it should work. But I did that to the human because the algorithm is used to the human, not used to something that looks like a rig of a human. So if you just do the rig, it might work, it might not. I haven't tested it, but I did the human itself because that's what the algorithm is trained on. And then it can create the open pose skeleton for me to be used on the diffusion process. You don't look, okay.
No. Sorry, can I ask one more question? Sorry,
Yeah.
when you said that, it triggered another question.
Oh, go ahead.
So the geometries go into the decoder. Those images are tokens, which are generic and a number of values. Is that correct? Am I interpreting that correctly?
So OpenPose outputs a 2D image.
Yeah, and that 2D image goes into the decoder, then turns into a token, correct?
Once you grab that image,
Yeah.
you send that image to the video one or to the actual ControlNet processor. That then becomes, you can use that to go into the latent itself, but you don't need that. OpenPose will just feed the data out of that. I'm not sure if it's going to be tokens because I'm familiar with tokens for text. I'm not sure I'm not sure if the OpenPose part would become a token. That's why I don't want to say it. I think it's just an image, and it's image processing. That's what the control nets do.
So it's different. I think what triggered in my head was that when you do in a control net, you're doing edge detection and you're doing the depth. So that's the image to image conversion.
Correct.
And then you put a text prompt to say what this image is supposed to be.
Correct.
Yeah. My question is like, can you not just have a generated image that has the tokens encoded as pixel values into the image? So when it goes into decoder, it will just generate it knowing what the token is.
I cannot tell that. Okay. I don't know if that would be possible. Through control nets, the control net architecture allows you just to provide pixel image, and from that pixel image, it provides information to the diffusion model as an extra layer on top of it to guide the diffusion. It's just using pixel data to rebuild information around it. So I don't know, I'm not sure if it's tokenizing it.
I'm trying to skip the entire text prompting section of it. I think what the problem I always find with continuity when it comes to diffusion models was that it's constantly like changing the token a little bit, so you're losing continuity. Like you have a gen from straight and it does a 1/4 degree angle. Because there's a minor change in the token number, the image kind of changes a little bit. So it's just like, and then when you're constantly relying on prompts, I'm dyslexic, so a simple spelling mistake can fuck up my prompt.
So I'm always using the same, I'm going to that journey right now. So I'm building a loader from a character that's helping me improve consistently immensely. I'm always using the same prompt base, and then I add something on top of it. And also locking the seed. Yeah. So that's my current strategy to kind of try to get consistent shots of the same character, different shots, same character. But that's the future. That's what I'm exploring. That's the next step of the exploration, for sure.
So can I just throw you the Actor Guilds agreement that is with AI and the film studios and how So I was on a show recently, Alona Holmes, and we, on the AI, we had to keep asking permission from the Actors Guild, are we allowed to use it? And the clear prompt was, assisted AI for depth mattes are okay. Anything that involves the actor gen has to be authorized by the Actors Guild. So, but on that basis, we have to offshoot so the guidelines are that we have to create a LoRa that's disconnected from the internet. That's not, or it has to be encrypted. How do you bring that workflow into this whole thing without actually like designing a whole new application for it?
So the beauty of this is that you're running all of that locally, and you can do that on your own network with Houdini and ComfyUI away from the internet. You don't need the internet for any of this. So if you have your character offline and your LoRa offline, you just bring the LoRa to ComfyUI, right? And it's not connected to the network, and this process is not sharing the data with anyone else. It's privately. You can run your computer that's isolated from the network, isolated from the network of the studio, even of the studio. So it's kind of hermetic close over there, and then you can do the operation there. But I find it very interesting you bring that information of how the guild is proposing those use, and I very appreciate you sharing that with us. Fun.
It's the fascinating part of this innovation workflow that a lot of these workflows are not tested or tried or experimented with, but they're happening at the same time as the guild requirements are popping up and trying to align with that. It's fascinating, and I really appreciate your questions.
Thank you.
Hello. How do you deal with the GPL3 version of the licensing to distribute this in the commercial software?
So the only part that we're gonna distribute is our integration. And our nodes, the way we're gonna distribute, we're gonna have a specific license for distribution. I'm not gonna announce the licensing type because it's not decided yet. But the idea is that what we provide, we don't have any AI model. We're not providing AI model. We're not providing a ComfyUI itself. We're providing a plugin that just makes your life easier between Houdini and ComfyUI. And that's like worry-free because there's no licensing around that in terms of like, yes, licensing for distribution, but there's no AI models that we're distributing. So that's why we're clean on that way.
Thanks.
Yeah, thank you for your presentation. I asked this question from a standpoint of a VFX artist who's worked on a lot of creature-heavy shows. And it's very interesting, looks very interesting, the stuff that you're doing with these characters. My question is, imagine a very complex hero VFX heavy shot, for example, like the opening sequence of Guardians of the Galaxy 3 with hero characters and complex animation. Can this workflow be used consistently on hero characters? And how much control does it give you? How much consistency would you get across various shots, etc.?
Thank you for the question. I'd much rather say that I haven't been to that part of the research that allows us to do multiple shots with consistent characters. That's exactly the next stop that I'm diving into. At this point, we just made sure that we have a pipeline that's reliable and sets the foundation for us to do the jump and continue the exploration, right? But I'm very, just like you, I'm extremely curious to see what happens if I deform my skeleton? What happens if I add more bones? How much can I stress open pose to bring me this, right? So that's why I don't have an answer for that. And I don't know if we're going to be able to do these amazing hero shots with diffusion. But I can say that I was very impressed by what we had just before, seeing that Gen AI explosion with just not, it's very fascinating. So I'm curious what's ahead. But at this point, I cannot provide you an answer like, is this reliable? Is this production ready? It's a research project. And we're just getting started in understanding what's possible.
I see. Thanks for the answer. And another, I guess, smaller question. With these models that you're using within the ComfyUI and Houdini, are they paid services? Some of them, for example, the op-resing models, would they, because like a lot of the op-resing models that you see online, you'd have to pay monthly subscriptions and stuff like that to be able to access them.
So the whole idea here is that we are using open source and we are not paying for it. So SeedVR, open source, distributed, research use. We can. If you want to be able to do commercial work with that, I will definitely go to the model card and read the descriptions. They do have a license for distribution. They might have something different for commercial use. I will definitely go to the model. That's why we have the model card there. And I can definitely maybe take a look at that after the presentation here. But the idea is that Topaz is very fun, but you got to pay for that. With SeedVR 2, it's open source and free to use. So.
And the whole purpose of this project is to try some workflows, to experiment, and then to put it into your hands and into the beta group to see where you can push it and see how far you can stretch it, and maybe use this as this learning starting point to take into production with some other inputs.
Hi, I just wondered in terms of the new machine learning tools within Houdini itself natively, that's a node-based structure and so on. And I wondered to what extent you can see that being able to take over some of the things that you're currently sending out to ComfyUI, because of course it would make sense to have things like attributes and all kinds of other things pouring into that same workflow. Or do you see the large pool of ComfyUI users as a kind of a forest to sort of pull from and maintain that as an engine outside Houdini that would be doing some of that work?
Ooh, that's a very interesting one. At this point, we look at this as a forest that we just kind of going, touching, experimenting, see what's possible. If this is gonna come to the main package, if we're gonna bring attributes directly, I really like the experiment, the MLOps. And they do have all these attributes and this idea of SOP integration, which is very fascinating. We haven't gone through that route because we just kind of went directly into ComfyUI because we want to drive from their diffusion architecture. But at the same time, let's see if the community enjoys it, if there is resonance, and if there are pathways for this to be used in an interesting and impactful manner, then we're going to make more decisions about it.
Cool. And off a slightly different topic, I noticed that the amount of bone architecture, for example, in whatever control net is producing as a skeleton is of course limited and based on a single camera perspective. It seemed to sort out some of the foot animation that was coming through from the quickly retargeted rig. So obviously there's a logic involved there in terms of the images that were produced with the girl with her trainers on the floor and the I think another foot contact thing. I just wondered if you noticed any small, tiny utility-based sort of benefits from having to force it through a type of logic that was fixing things like foot sliding or any other kind of classic CG problems with skeletons.
So for that, Michiel, which is also here, I think it's going to be your guy. Because, for example, he's proposing within the side effects team, they have a ML solution for fixing bone structures. And that's part of the Sigrif talk, or Equinox talk, I think. It's going to be out very shortly. And they do ML to fix those rig errors. So that's not going to be handled by ComfyUI. That's handled in Houdini through the machine learning algorithms and through the SOPs that side effects is bringing them in.
Yeah, it just seems like a really great place to say, I wish this software understood that this can't happen with a foot, or this should always look this way. So I'm just interested in the kind of the extra buddy that this might provide for certain artists to say, look, here is some logic. You know, you should already understand this sort of thing.
I think that's very powerful.
And then give it the control to be able to tweak it from there, right? Yeah.
When you get your motion into Houdini and you have Apex tools or KineFX tools, so then you can process your motion. So for example, here you have some foot sliding, you have the stabilized motion SOP. So there you can do stuff like if there is drifting, basically over time, there is a small change in each frame of the movement of some joint, snap it to the original place. So only when there is a bigger change, only then use the new motion. So there are tools in Houdini that you can process this motion, and then after that you can output the open pose skeleton. So this way you can do extra animation in between, the capture and the ComfyUI generation.
I'm a huge fan of the crowd setup in Houdini. There's so many things you can do to fix things, especially with the upgrades of KineFX. So I use that to fix whatever issues I had on the mocap. So then I have like a clean information for the open pose there to play with.
I think there should be like a skeleton that renders into the open pose. So it's not just because I think this wasn't really clear that once you retargeted the motion to the character, did you use the image of the Tommy?
I use the image of the Tommy,
okay.
And looking at the image of Tommy, there is an inference model called from the open pose
okay.
that then assumes the skeleton.
Okay.
And that's something I want to explore in the future. Can we skip
I think
the Tommy part and just kind of build the retargeting?
You can render the skeleton into open pose. I think.
That's exactly. That's kind of also for the next steps. Thank you for all the questions. I much appreciate it.
Hey, you demoed that really nice workflow where you could just kind of drag and drop an image or something and it generated the Confi graph inside Houdini. The other nice thing is kind of if you're missing models, Confi will download them for you, I believe. I'm not that au fait with it. Do you support that kind of thing? So if I dragged and dropped an image in there and I'm missing all the models and whatever bits and pieces it requires, can you kind of auto download those, or even nicer, because I'm unfortunately on an air-gapped system because Netflix, etc. Is there a way you could generate me a list of what I need to download to make that work?
That's a very interesting question, and you provided some good solutions for that. Right now, we are relying on ComfyUI to manage the models on yourself. You can go to Hugging Face and download those AI models, or when you drag and drop a JSON to ComfyUI, it's just going to give you a hint of like what's missing there. Right now, we are not handling if you don't have the models. Basically, once you drop in, we have that refresher that allows you to look at all the models available in your system. And then you can pick and choose, but we are not planning on having our own manager, for example, for that. And that's the whole idea of like using ComfyUI, is that they are doing this heavy lifting of creating their environment for diffusion. And then we just kind of make use of that.
But do you think, like, because obviously when you run that workflow for the first time, it's going to throw you an error. Could there be a nice kind of user thing where it says like, oh, you're missing this model. Do you want to?
Right now, we are not, basically, it's going to give us the model, and it's not going to give you the information that is missing the model if it's not installed. Although you would get that in ComfyUI, we don't get that in Houdini, but that's a very important feedback. And maybe just having a list of what is missing can be a powerful solution for that. So
if you don't provide the fact that the model is missing, how are people meant to debug the thing?
That's why we have ComfyUI running.
Oh, okay. So
because ComfyUI is the
ComfyUI.
Exactly. You're always going to need ComfyUI. ComfyUI can also ComfyUI always needs to be running on the background, the local network. And then, for example, if you just pop it open and drag the model there, then it's going to tell you what's missing. And then you can use the manager there to download. So the idea is that you're not handling the models in Houdini. You just have them already ready for you to use. But if you need to download and manage them, you go to ComfyUI. We're not planning to have a manager for models that for ComfyUI instead of Houdini. Although SideFX does have now AI models for the ML upscaling, and SideFX coming on with their own solution for managing that. But that's not something we are looking at the moment.
Okay, thanks.
And remember, this is a research project, not a SideFX developed production-ready tool, right? So this is a research project. Try some things. One of the neat things would be to see if you can take this and production test it and sort of convert it into something that you can actually use in production. But that's not really what it's designed to do. Final question.
Hey, great presentation. I'm just wondering, what sort of data is actually flowing between those Copernicus nodes? Like, is it the actual data, or is it just like a communication channel back to ComfyUI running in the background? How does that work?
So ComfyUI runs as a server in your computer, Python server. So it allows you to access an address. Once you reach that address, then you can do you have a UI for you to manipulate the nodes. So what we do is that we look at that UI, we look at the foundation of it, and we look at the API calls. So ComfyUI has an API calls, and then we build a front end for it inside of Houdini. So we are able to replicate the nodes, replicate the workflows, replicate everything, just looking at the API calls and a lot of Python as well.
Okay, so it's like you're basically building the graph and calling ComfyUI to execute.
Correct.
Right. Okay. Thank you.
Terrific presentation, Rafa.